everyone, welcome back. I just wanted to do a quick video to show you how to use the Aztec C Compiler and do something more interesting than just hello world. We'll be doing the Fibonacci sequence, both with and without recursion, just so we can see how to pass parameters into functions, do functions, and stuff like that, using a very antiquated dialect of C. I'm using my Z180 computer. So let's get right into it. Let's just reboot the computer, boot into CPM, go to drive J, and let's just get started in programming. So let's do the recursion first. So for C, obviously, you want to declare your functions first. So let's do the first function. We're going to have two functions, main and fib. Let's do the fib function first. Now with this dialect of C, you don't have to do function types, and you don't even have to pass in variable types in the parameters. That's handled in the assembler. It's very straight one-to-one conversion. I find that a little disorienting, but you know, it is easier, I guess. Let's do it. If n less than equal to 1, then return n. I'm never going to get used to no backspace. And then let's do some recursion here. The keen-eyed among you might figure out what's going on here. Okay. So that is the fib function. Let's do the main. Okay. We'll ask the user how far along into the sequence we want to go. Sorry about that. It's number. Okay, that looks about right. Let's do recur.c. Okay. And now let's compile it. And let's run it. Boom, 9th one in the series is 34. Okay, that is how you do recursion. Let's try a bigger number. And you'll tell me if you see something weird. Okay. Seems alright. Jesus. Okay, that's a weird answer. We'll get into that. But in order to show you why we get that answer, let's do the non-recursive version of this. Okay, let's start doing the non-recursive method of calculating the Fibonacci sequence. We only need one function. But we need a lot more variables. Okay, let's compile it. Okay, now let's run it. Okay, looks like it worked. But remember that because we started at a different index, in order to get the same number, we have to do one more, 34. Okay, let's do an experiment. I want to do the first 100 terms of the Fibonacci sequence. Check this out. Now, isn't that weird? This is running a Z80 system, Z180, system. Maybe I'm running out of memory. Let's try something. Let's try something here. Here I have the same exact code, but set up so it can run on, a desktop. Let's try running it. See what happens. Okay, let's do 100 terms. And let's pull it up side by side. Well, it looks like I run into issues way faster on the CPM version than I do here. This looks like just the int variable type just isn't big enough to handle such a huge number. And there lies the problem. What happens if I change int to a short? Now let's try running it again. 100. Oh, look at that. Isn't that something? We get the same exact output as we do on the CPM system. That is because on Aztec C, on this version 1.06D or G, I can't remember which one this is exactly, the int variable type is only 16 bits long. You know what also is 16 bits long? A short. On desktop, using, I think it's C99, the int type is 32 bits in width, not 16. So when we did it on the desktop, we got much better precision, although we still ran into issues because we ran out of bit space, but it lasted longer. So that is a fundamental hindrance, should I say, with CPM, with the Aztec C compiler on CPM. So that's just something to look out for, is that the int is not as big as the int on modern systems. That wraps up this video. I just wanted to show you how to pass some parameters to a function and do a little recursion using the Aztec C compiler. I'll put two links down below for the write-up and the it's not quite the manual, but it's like another technical document for the Aztec C compiler. Both are very short PDFs, so easily digestible. So don't get too intimidated by that. Anyway, see you next time.